Alright, this video is to show you how to do the flame test for the metallic ion lab. When we did the flame test in class, I want you to record those colors. That's what we found in class. I'll hit pause and write down those colors. What I'm going to do now is, of course, all this information here is found from your reading. Notice what this back chart looks like. See the back chart here? Notice it resembles what I am going over right here. This is the same thing to show you how to do this. Here's the equation we're using. E equals HV, C equals lambda V. We write those as our triangles. I'm going to go C lambda V first and E H V. We know C is always 3 times 10 to the 8th. And H is always 6.6 times 10 to the negative 34th. Okay. What we're going to do is we showed you the colors on the front, what color they change to. So if we have green, we look on our sheet and we find that green is 550 nanometers. So that would be our wavelength. Problem is, our wavelength needs to be in meters. So we need to change 550 nanometers to meters. We're going to do that right here by putting 550 nanometers. What goes to the bottom has to be the nanometer, and this right here says our 1 e to the 9th equals 1 meter. So I'm going to put 1 times 10 to the 9th equals 1 meter. And now we can put that in our calculator. To put that in the calculator, don't forget, we type in 550 divided by 1. We don't hit times 10, we hit EE and 9. It equals, and I get 5.5 times 10 to the negative 7. 5.5 times 10 to the negative 7. 5.5 times 10 to the negative 7 is my wavelength. Now that I know wavelength, I'm trying to get to energy. Well, which equation has energy in it? This equation does, but there's no wavelength. But there is a frequency. So I'm going to use this equation here because I know wavelength and I know C to find my frequency. And then once I find my frequency, I can put it into this equation, find my energy. So let's find the frequency. To find frequency, I see that it is going to be C divided by lambda. Frequency equals C divided by lambda. C we know is 3 times 10 to the 8th. Lambda is 5.5 times 10 to the negative 7. Let's put those in our calculator. We're going to hit 3 EE8 divided by 5.5 EE negative 7. Again, I'm hitting EE because you do not hit times 10. It equals, and that gives me 5.5 times 10 to the 14th. 5.5 times 10 to the 14th. So we'll put that in for my frequency, 5.5 times 10 to the 14th. To find my energy now, energy is H times V. So energy equals H times V. H is always 6.6 times 10 to the negative 34th. And so multiply that times our frequency, which we just calculated as 5.5 times 10 to the 14th. Put that in my calculator now. I'm going to take my 6.6 EE negative 34 times 5.5 EE 14 equals. And I get 3.6 times 10 to the negative 19. Equals 3.6 times 10 to the negative 19. And this is in joules. 3.6 times 10 to the negative 19. And so that's how we work. Every one of those problems are all worked the same way. If you do this right, every one of this column should be to the negative 7. Everything in this column will be to the 14th. Everything in this column will be a negative 19. So going back to your lab then, we see go to the front. We see lithium is red. So on your lab, you come over here for lithium. You write the word red. You then change its wavelength to meters, just like we did, and then take meters, take wavelength, change that to frequency, and frequency to energy. Again, all these, your answer should be to the -7th. All of these should be times 10 to the -7. All these should be times 10 to the 14, and all these should be times 10 to the -19, or at least close. -19, -18, 14, 13 should be close to that. Okay, and for these answers here, I would like for you to use Roy G. Biv as your choices. So which color has the highest exchange of energy? Well, we know violet has the highest energy, so violet would be my answer. So use Roy G. Biv for those right there.